Okay, we're going to talk about amines, and a fairly good starting point to talk about amines is to talk about ammonia. We've got ammonia there, NH3. It's got a lone pair, which tends to make it a good base, good at accepting protons. Now, the amines are categorized into primary, secondary, and tertiary. So a primary amine, that is when you replace one hydrogen on ammonia with an alkyl group. So for example, the simplest amine is going to be methylamine. So you've got CH3, that's a primary amine, methylamine. You could have ethylamine, that would be the next simplest one, and so on. Okay, so in a primary amine, you've only replaced one hydrogen, so you have the NH2 group. Okay, in a secondary amine, you've replaced two hydrogens with an alkyl group. So maybe a simple secondary amine would be dimethylamine. Okay, that's a secondary amine. Let's talk about tertiary amine. Well, a tertiary amine is follows on, doesn't it? It's going to be when you replace all three of the hydrogens with an alkyl group. So tertiary amine could be, see, methyl, dimethyl, ethyl amine. So that's a tertiary amine. So I suppose if you notice, there's one difference between tertiary amines and the other two is that they can't form hydrogen bonds because you don't have there's no H bonding in that, because this one's got a hydrogen attached to the electronegative nitrogen and a lone pair there. Obviously the primary amine's got two hydrogens attached to the electronegative nitrogen, so they can form hydrogen bonds, whereas in the tertiary amine there's no possibility of that occurring. So tertiary amine's a little bit different. Do be careful that you don't confuse this primary, secondary, tertiary amines is a totally different nomenclature to primary, secondary, tertiary alcohols, where, so for example, just to show you, if you had this methyl propantuol, that is a tertiary alcohol. But if you had a very similar looking compound where you replace the OH with an NH2, it would not be a tertiary amine. That would actually be a primary amine, because the nitrogen has still got two hydrogens. You've only replaced one of the hydrogens with an alkyl group. So the primary, secondary, tertiary nomenclature is different with amines, so don't confuse that with the other two. Okay, now let's talk about the acid-base properties of ammonia now, and we'll see that the amines behave in a very similar way. So you should be okay with ammonia. If you put ammonia in water, you should remember this. It's an equilibrium reaction. It's a pretty weak base, and so only a small proportion of it will become NH4+, but it will be slightly alkaline, the solution. So that's ammonia in water. If you react ammonia with an alkali, so if you get NH3 and you react that with OH minus by adding like sodium hydroxide, then, sorry, with an acid, beg your pardon, react with an alkali I'm talking about, because say you react with HCl. Now HCl is a good acid, and that will protonate all of them. It won't be an equilibrium reaction. You'll protonate it all, and you'll form NH4. You'll form ammonium chloride. You'll form the ammonium salt. This is an ammonium salt. Now the same thing happens with with amines. So let's take a primary amine. Let's take ethylamine. So it doesn't. You'll get an equilibrium reaction going on with water there. You will get a small amount of it will form CH3, CH2, NH3 plus. So a little bit of it will react. But if you add some acid to ethylamine, then you will form you'll protonate it, and you'll form CH3. Sorry, not an equilibrium sign there. It's just a close to completion. CH3, CH2, NH3 plus. Okay, so you've seen there the primary amine acting as a base and the HCl acting as an acid. Right, there's let's just talk about the physical properties of amines. If you get, let's say we get butylamine. Okay, so we're going to do this with butylamine, which is going to be CH3, CH2, 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 NH2. So it is right, it's a primary amine. Right, if we get a beaker of water, and if we put some butylamine in there, you find that the butylamine, it doesn't mix terribly well with the water, and it floats on top. Butylamine, and it also doesn't smell very good. It gives a really nasty smell of rotten fish. Okay. Now, if you add some HCl to that, so add a bit of dilute HCl, what happens is the layer disappears. Okay, it becomes soluble. You form a solution. And the reason we form a solution is because what's happened to the butylamine is it's gone from being C4H9 NH2, and it's now C4H9 NH3 plus. Is positively charged. Okay, because it's charged, it dissolves better in the water. The water molecules, obviously the negative ends of the water molecule, the oxygen, is going to, like it will do with any ionic compound, and that will make it dissolve. This stuff, when it's butylamine, when it's NH2, it doesn't dissolve terribly well, because you've got this bit which can form hydrogen bonds, but then you've got this bit here which is just going to form van der Waals forces, so it tends not to be too soluble in water. So it forms a layer on the surface of the liquid there, it doesn't mix. And you can probably predict what would happen if you add some sodium hydroxide to that. Well, it goes back, it will separate out into a layer again, because you will have removed the proton from the NH3 plus and turned it back into NH2, and they can't mix as well with the water. Also, you notice that this you smell here, you do not get this. There's no smell, and that's because it's not volatile anymore. Why isn't it volatile? Well, it's because it's charged. So it's interacting with the water molecules. It's staying dissolved in the water, so it's not coming out as a vapor. Whereas in this case here, it does smell quite strongly. Okay, so a little introduction to the amine group, difference between primary, secondary, and tertiary amines, and just a little bit of sort of physical properties.